Hi, everyone. We are the Wearable Learning team, and we worked with the UMass Advanced Learning Technologies Lab. Today, we're going to be talking about science learning through wearable learning software.
So to begin with some context, video games have a huge influence on young students today. In fact, studies show 97% of teenagers in the US play video games. Given this, many researchers believe video games can be a powerful tool for fun and engaging learning compared to traditional worksheets and readings. However, the use of educational video games is fairly new, and researchers are still exploring what design frameworks and features make an effective and fun educational game.
So what is wearable learning? Wearable learning is a cloud-based app created for wearable and mobile devices. Originally, it was designed for math games, which have a focus on interactivity and embodied learning. Through wearable learning, teachers and students can both play and make games, and the game creation is based on a simple state machine programming language, as you can see here on the right.
Wearable learning is a great platform for math learning with proven benefits, and we believed that it can also be useful for other subjects. We were interested in exploring the effectiveness of the platform for other subjects. Through our experience creating our own games on the platform, we noticed a few limited options. This motivated our research, which was focused on discovering the effectiveness of the existing platform to teach science-focused games.
We plan to split our research up into 3 research questions which we intend to explore. In our research, we plan to investigate these questions. What game features are used or desirable in online science educational games as opposed to math games? Second, given its current form, what can wearable learning technically handle in terms of supporting gameplay creation and management of science educational games? And third, what new capabilities could be added to wearable learning to create better science educational games? The 4 games that we created to answer our questions are Cell Speed Dating, which is a collaborative game that teaches about cell organelles. States Matter, a visually intuitive game that teaches about states of matter. Fantastic Forces, a physically dynamic game that teaches about forces and motion. And fourth, Water Cycle, another collaborative game that teaches the different processes involved in water cycle. The features wearable learning already offers that we used to make our games were drag and drop color sequence, video demonstrations, text entry, and lastly, multiplayer feature.
After creating our games, we surveyed graduate education students. The results of all 4 surveys are broadly summarized by this bar graph here. We asked participants to rate their experience with their games from 1 through 5 on 5 categories. 1, whether the game enriched the learning experience. 2, the effectiveness of the highlighted feature. 3, usability of game mechanics. 4, how engaging the game was. And 5, the likelihood they would implement the game into an actual K-12 classroom. The colors in the bars correspond to ratings 1 through 5, while the numbers inside the bars represent the number of people who gave that score. Participants generally had a positive impression of our games, with 70% or more of participants rating each category a 3 or more across all games.
So we took this survey feedback from our participants and compiled various possible features to tackle issues that were suggested in the surveys. One of these was text stripping, which removes spaces in the beginning and the end of text input answers. This makes the input answer method clearer. Another was a skip button, which prevents students from being stuck at a certain state if they're confused about it. And another is image display, which changed the color sequence blocks into images, which directly represent their elements. And this aims to make the science concepts more visually intuitive. We demoed these Android app prototypes using Kotlin and XML. And the app version is as opposed to the current rolled out version of wearable learning, which is accessed through our website.
We hope that these features can be implemented into the platform, as we believe that they will highly benefit science educational games. Based on survey feedback, we hope to collaborate with teachers in the future to create these games. We also hope that the science games created by wearable learning can be tested in K-12 classrooms like the lab has done with math games in the past. Although the research is still technically ongoing, we hope that what we have discovered through our research will allow for better science education game playing, management, and creation. Before we open it up to questions, we just wanted to say a thank you to our lab mentors, Sai, Francisco, and Professor Arroyo for their support and guidance, and would also like to thank Professor Toda and Hia. Thank you.